Good morning. Thank you very much for joining us today for this webinar. We welcome you all. Today we are going to talk about building and deploying SaaS solutions. And the webinar has been divided into two parts. The first part is going to focus on migration and deployment challenges of a SaaS application, whereas the second part is going to talk about the application engineering and architectural challenges of building a multi-tenant SaaS application. Today we have with us Milan Kirvatkar, AVP Cloud Services from Symphony, who will be taking the first part of the presentation. Milan actually has over 25 years of experience with a demonstrated ability to transform businesses from customer segments like high-tech manufacturing, retail, and distribution systems. His experience ranges from designing and implementing solutions to global delivery models, which can impact on ROI. He has also handled global sales and PL responsibilities during his long career. He specializes in leveraging emerging technologies like cloud computing to solve business problems. Ram Kumar is the Director of Product Management at Texelo, and he has over 20 years of experience in various product management and marketing functions. So let's start with the presentation from Milan. Milan, please, you can start. Thank you.
The focus is going to be on multi-tenant SaaS models. I will not be going deep into the whys and hows of it, but rather drawing your attention to what are these factors which we need to take into consideration when we are planning to deploy SaaS solutions. So if we look at the entire SaaS migration spectrum, the assumption here is great. So if we look at SaaS migrations, there are basically three aspects I would dwell on. One is the product engineering considerations. The other are the cloud considerations or the deployment considerations. And the third is how do we go about achieving these? Do we do it ourselves or do we kind of ask someone else to do that? And again, under the engineering considerations, we would talk about three aspects: the application architecture, which is going to be the main topic for RAM actually. The migration approach, which means once we have decided on the target architecture, what are the different approaches? And once we have migrated, what are the engineering considerations once we are there, once we are SaaS? And on the cloud deployment side, we are going to look at the cost economics of cloud. We are going to look at the importance of the deployment architecture. And then as we will look at the migration engineering process post-migration, we would also look at post-migration cloud operations. So let us look at the architecture aspect. So since 75% of us are on-premise today, now maybe it's quite possible that these aspects of application architecture, for example, if we look at availability, okay, I'll start with that and then I'll come to multi-tenants. Many of us know that stateless design is one of the ways which contribute, or one of the factors which contribute to availability. Or caching contributes to scalability. Sharding or partitioning contributes to scalability. Okay, the data connections have to be abstracted; they cannot be deeply embedded. And similarly, when we look at the operational aspects, so though there will be monitoring tools, there will be tenant management systems at the cloud level, but at the application architecture level, there are certain aspects which have to be taken care of. Now, would you like to detail this slide a little bit so that people get an idea what we are talking about?
Yeah, okay. So I will just give a brief overview here. Anyway, we are going to have a following topic, more detailed coverage is going to be there in my presentation, but very brief overview here that while as you mentioned, a lot of these metering and tenant management is part of these cloud providers offerings. But even at the application layer where you are architecting your application, you have to look at usage monitoring depending on the business model that you are going to use. For example, let's say you are building a survey product, you need to know how many surveys have been completed, or if you are building an email marketing tool, how many emails have been sent, so that you can link the licensing and packaging of your product to your subscription customers based on the usage they have done and limit their usage and things like that. So these have to be handled at the application level and not at the cloud deployment level. Similarly, the ability to create a new tenant, provision the tenant, and run some scripts and create all the default data for those tenants, or creating roles and authentication for various tenants. All these have to be clearly thought through during the architecture design stage itself, which we will cover during my session. Same is the case with multi-tenancy, how we are going to isolate the data between tenants, how are we going to provide customization capabilities for different customers while still maintaining a single code base where a single instance is being shared across multiple customers. How are we going to customize the access control policies for different customers? So these are the things that have to be considered during the architecture stage of the application before you start a new development or when you are migrating an existing on-premise product to a SaaS architecture. Milan, you can proceed.
Thanks, Ram. So probably if we take a look at where the participants are today in terms of these features, it may be useful, right, Ram? So that would be our next.
No, we have a poll question on the engineering processes, Milan.
Okay, fine.
Which is going next slide, yeah.
Yeah. So we had a look at some of these aspects, the architectural aspects, right? Now the question is, from on-premise to the target architecture, how do we move there? So 4 approaches are available to us, and there are pros and cons of each one of these. But there are scenarios depending on what is the baseline state today, where we are today. The selection of the right approach is the key. For example, if the application is a good, has a good web architecture, so to say, basically a thin client application, it's also possible for the sysadmin team to create a VM image of it. It's not like a legacy code and it doesn't have any modernization needs. Probably rehosting it on an IaaS could be a good starting point before we start optimizing for multi-tenancy in the whole ecosystem. But if it is slightly more complicated than that, where we have to kind of recompile or repackage it to make changes to the configuration so that it talks to the infrastructure, it talks to the database, and at the same time there is no market pressure in terms of the bringing the SaaS product to the market. The requirements are fairly stable. Probably refactoring the code could be the right starting approach. Okay, here we are talking about migration approaches, the transition approaches, not the final state. However, if the code, it's a legacy code, we want to add significant functionality and partial code reuse is possible, we could use one of the past platforms, so to say, to revise it. Or when none of these are feasible, we are under pressure for a time to market, and the case is for rebuilding, and vendor lock-in, etc. are not an issue. And what we want to do is first create a proof of concept for SaaS. Probably rebuilding, which is rewriting the application, is the best suited approach. The point here is not where we are today or which approach we want to take. The key here is that the migration success depends on right engineering the approach. What we have seen in our experience is that we tend to either over-engineer or under-engineer. That is the underlying message here, which means that either we try to go to the SaaS model, without really making necessary investments in the in re-architecting the whole thing, or we over-engineer to the extent that before we really test the market, SaaS is a new business model, and it takes time to transition to that, for the organization to learn the new way of doing business, and for getting customers in that model. And if we over-engineer, which means we make a lot of investments upfront while we are testing the waters, sometimes the feasibility becomes an issue. So right engineering is the key here. Okay. So moving to the post-migration engineering process. Now, say we have migrated to SaaS. There is one aspect which is post-migration engineering aspect, which many a times what we have seen takes a backseat. So let me give you a few examples. Now these processes I'm talking about are not exclusive to SaaS. Okay, they are all so-called, kind of best practices or available techniques, approaches, which are not mandatory, so to say, when we have on-premise softwares. But what happens is there are two critical aspects of SaaS, right? One is the short release cycles, because the long upgrades are ruled out. So there are frequent releases with incremental features or patches. And especially in a multi-tenant model, the quality benchmarks both on the functional and non-functional side are extremely high, because there are SLAs and the penalties and costs of downtime could be very, very severe. Now the question is, are our engineering processes geared towards meeting these? So some of the approaches which have been traditionally, even for on-premise products, but which have been proven to be successful for achieving these are agile development process, the iterative process, having complete traceability in the development life cycle, the automated patch management. Okay, the key here is that in on-premise, the fixed patches or the patches would be released, and the customer's IT departments would apply those. Now, in a SaaS model, one is that the responsibility comes to the vendor, and not only that, now since it is not decentralized, and you're not really giving a common window to all the people where it is applied simultaneously, it has to be done in real quick time and as far as possible without interruptions. So the question is, are we geared up for that? Similarly, when it comes to the testing side, the performance, scalability, reliability, availability, all these tests, are we equipped with the necessary processes, tools, and do we have the necessary experience to perform these, which are the key to any SaaS product, especially multi-tenant, right? These are the keys. Continuous integration, daily builds, automated builds, daily testing in a almost a production-like environment is very, very important if we want to achieve quality while releasing, right? Because it's not going to be the same. Now, all of these may or may not be applicable. That will also depend on what kind of SaaS application we are talking about. But research shows that most of the successful SaaS companies have adopted these. They have implemented these. Now, let us come to the cloud aspect, which is the host. As a hosting model, let us look at cloud. And why should the SaaS the companies who want to move to SaaS, they should look at cloud. So here are the three options available to them: self-hosted, hosted SaaS, which is hosted SaaS in the sense with a third-party service provider, either co-located or some hosting service provider. And the third option is cloud. And here cloud is used in the sense of public cloud. Okay. One point I would like to make here is, though there is a lot of debate on public and private cloud, for a SaaS vendor, typically private cloud may or may not make much of a sense. The reason being that whatever they do, it still remains outside the firewalls of their customers. So it's easier for them to look at the public cloud option rather than investing in their own infrastructure, unless there are business issues in the sense, the regulatory or the compliance or the privacy, that kind of issues. Now, from a cost aspect, self-hosted will always have an upfront investment. Hosted SaaS is pay as you go, but it is not elastic. It's kind of a rental fee. The true pay as you go or pay by the drink is SaaS on cloud. Similarly, when it comes to the maintenance aspect, so if we are setting up our own data center, it goes without saying that it requires the IT resources to maintain that. In a hosted SaaS model, the basic infrastructure is always maintained by the service provider, but there are certain softwares, third-party tools which sit on top of that, for which the IT of the vendor is responsible. And when it comes to cloud, yes, it does require, against a common notion that when we go to cloud, the IT staff goes to nil, which is not the case. It does require resources for monitoring and administration, but it is minimal. So it's the least in the three models. Similarly, the impact on provisioning in the own data center, it's like any on-premise provisioning. It takes long time. Hosted SaaS, because it works in a rental model where the capacity is blocked in advance, if we want to make any changes, probably they have a few options available with them. It may be a little shorter, but still long. But SaaS on cloud is truly elastic. Provisioning is very, very short. Okay, it's almost on demand. And then hardware, it's our own hardware, and in case of hosted SaaS, the basic infrastructure is hosted, but may or may not be. It all depends. Okay, the backup, scaling, recovery, all these things we may still have to take care of ourselves. Now here, the entire thing is provided by the service provider. So what is the impact? The impact of all these four factors put together is, there is a study actually which shows that for the SaaS providers moving to the cloud model, the reduction is in TCO is as much as 80%. Now, it may or may not be. That's the potential we are talking about. But the point here is that it may be worth a study or an assessment, or to do some kind of an analysis whether this is a good option for hosting or not. And especially, I would say that for applications with fluctuating workloads or highly elastic workloads, that's where actually the maximum saving comes into picture. So, having looked at cloud as an option, now what are the things which we need to consider? Now, the way we talk about application architecture, the deployment architecture, if we are doing cloud, is equally important. Okay, and we are again talking about the same quality attributes. Here are a few samples, but there are many more. Like, say, for example, the most critical ones: availability, scalability, and security. Now, there are failover mechanisms provided by the service providers, the cloud service providers. So things like, for example, the database could be, we could have a master-slave relationship with replication across zones, or using elastic IPs to bring up new instances. So right now I'm talking in the context of Amazon, but here actually the way these strategies are adopted are quite specific to the platforms, or automated backups. Similarly, when it comes to scalability, cloud provides load balancing. There are built-in load balancers. Then there are elastic IPs attached to these, load balancing instances. The messaging service or the queues are provided so that if your components are, decoupled, and then they're loosely coupled, and then there are queues which are connecting them. Similarly, multi-factor authentication on security side, network security in terms of, denial of service attacks and port scanning, and access control using access control services of, for example, of Azure. The key here is that suppose you have decided to move to SaaS. If you take a decision that cloud is going to be my hosting model, deployment model, one needs to make a careful choice in terms of how many of the quality attributes have to be addressed at the application level and how many of these have to be addressed at the deployment level. The experience here is that if one leverages the features of clouds for achieving these, probably trying to achieve everything at the application level goes down, okay, and which actually reduces your investments. So a careful balance has to be struck between how are we going to argue. Now the question is, having migrated to cloud, how do we manage the operations? Now we need to, all of us understand that in a SaaS model, what was being done, on the infrastructure side, what was being done on the by the IT department of the on-premise customers. Now the responsibility is shared between the SaaS vendor and the infrastructure service provider, the cloud service provider. Okay. Again, there is a lot of work here, though not, when I say lot of work, it doesn't mean that a lot of people are needed, but we are talking about the knowledge and the skills and knowing what are the right things to do which need to be in place if we are considering cloud. Now, even if we are migrated to cloud, both the infrastructure and applications have to be monitored, okay? So infrastructure for things like memory usage, CPU usage, number of calls, latency, right, input, output. That is the infrastructure monitoring, and we are talking about the performance tuning, we are talking about patch management, we are both at the OS level and at the application level. So, and then again monitoring the uptime, availability. So this is very, very critical for cloud, because continuously we have to take decisions as this data comes in, and especially when we are new in the sense when we have freshly migrated, monitoring this data is very, very important. Similarly, when it comes to provisioning, one of the ways of providing services in a SaaS model is, say, through a service catalog, or having multiple services where rather than having features or modules, they are exposed as APIs through web services, and customers can kind of provision those services and configure those. Now, how do we provide for that in a cloud environment? Infrastructure provisioning is, yes, it is on demand, but there is a way to do that. There is a way to provision the infrastructure very, very quickly. Building in the auto scaling feature, because all of us know that the main advantage of cloud is pay as you go. But unless we have the auto scaling feature in place, the pay as you go really doesn't come into practice. A normal misconception is that if I have migrated to cloud, all these things will be automatically provided, which is not the case. The fact is that it is facilitated by the cloud service provider, and still there is a layer between the application and the cloud service provider, which has to be taken care of by someone. It could be in the form of a one-time development of, say, a management console or a self-service portal, or using the APIs, or it could be an ongoing service kind of a thing, which has to be designed to make use of these. So, for example, when we talk about contract management, so how do we facilitate pricing? How do we facilitate metering, which is usage monitoring? And how do we convert that into billing? How do we so SLA management? For example, if the cloud provider is giving 4 nines as an SLA, and my customers, if I'm selling to enterprise customers, demand 5.9 SLAs, how do I improve on that availability? And how do I monitor and report SLAs and give all those credits and debits and manage again what I need to, So the point here is that if I'm thinking of moving to cloud, all this has to be thought through. A careful assessment is needed that what will be automatically available by the cloud, and none of these things, by the way, are available as a de facto, off-the-shelf kind of a thing, but they are provided for. Similarly, when it comes to tenant management, creating a user or sysadmin for the tenant, giving them access rights, and allowing them to create users, then provisioning the instances for the if it is not multi-tenant, and in multi-tenancy, of course, if we need to select a larger instance or whatever. And then how do we help the tenants to onboard their customers very, very quickly? That is the key. Because in earlier cases, it used to be long implementations, right? So data migrations, integrations, even if these things were managed in a kind of a semi-automatic model, it was okay. Here, the downtime is going to be minimal. So all the customers, end customers, also have to be onboarded very, very quickly. Operations, okay? And this is one area which has to be planned as a part of the migration strategy, as a part of the overall roadmap for moving to SaaS. Very, very important. Now the question is, all this, whatever we saw, whether we should do it ourselves or whether we should outsource it, right? So if the expertise, it's an assumption, and what we saw partly in the survey also, that expertise would be normally low, and because it will always be a first time for the SaaS vendor, right? Whereas if you outsource, they would have done it number of times, which leads to a high risk if one is trying to do it internally, and it's low because of the learning curve or the experience if you outsource. Time to market, because of the above two factors, because if the risks are high, then the planning time, approval time, getting into putting all the mitigation strategies in place is going to be high, and obviously the time taken is also going to be longer if the expertise is low. So the time to market is going to be high. But at the same time, the plus points of doing it yourself are control is very high because everything is internal. There is no dependency on a service provider. Governance is low. It means because you are doing it internally, so the oversight, management, supervision, governance needs are low. Whereas if you outsource that, those are going to be high. But the key issue here is that the people investment in building those skills, gaining that expertise is permanent even if we bring some experts on board. But when you outsource, basically you are paying only for the transition and not, and it gives you time for training your existing people, training your the current resources. Because remember that even when one migrates to SaaS, in majority of the situations, the on-premise and the SaaS versions would run parallel for a substantial period before really, if at all, someone decides to, shut down the on-premise version. Slide, right? And with this, here is my email ID, and feel free to reach out to me even after the webinar if you have any questions. And with this, I would hand it over to Ram and for taking it forward to the main theme of our today's presentation, on multi-tenant stack.
Thank you, Milan. So what we are going to cover in this part of this webinar is to look at the technical stacks of the presentation today, which is the multi-tenant stack. So we are going to talk predominantly about multi-tenancy and the technical challenges of multi-tenancy and how you can solve some of these challenges using a multi-tenant SaaS framework. So the first part of the question is that what is the SaaS maturity level that we need to choose? And it varies from situation to situation and customer to customer. For example, depends on the number of customers, the number of tenants that you are expecting for your product, what is the size of your product, and depending on that, the time and cost might vary substantially between choosing a model where what we call as maturity level 1 or 2, where there is a separate instance running for every tenant or every customer on the cloud or on the shared data center. Whereas in maturity level 3 and 4, you have a single instance servicing multiple tenants and multiple customers. So difference between these two approaches is that the maturity model 1 and 2 is high on OPEX and low on CAPEX, which means that you spend a lot of money on the deployment cost because you pay for every instance for every tenant you pay a deployment cost. But there is not much of re-engineering or re-architecting required in your existing on-premise application to go to the maturity level 1 or 2. You can little bit of modifications, you will be able to host it on the cloud and offer it as a SaaS to your customers. Whereas if you want to go to maturity level 3 and 4, it's a little high on CAPEX for you, because you are going to spend time and money in terms of R&D, in terms of re-engineering, architecting, re-architecting or rebuilding your application to support this multi-tenancy, either internally or by outsourcing it to a partner like Symphony. But the operation cost will be substantially lower because you wouldn't be paying, if you have 100 customers, you wouldn't be paying for 100 instances. You probably will have 3 or 4 instances which are servicing hundreds of customers. So that is the balance between choosing a maturity model 1 and 2 and choosing maturity model 3. So let me move on to the next slide. So if you look at a multi-tenant application, there are 3 major components, 3 major layers that are required in a multi-tenant application, what we call as the plumbing stack, the engineering stack, and the operational stack. So I'm going to cover many of these things in a little more detail in the coming slides, but this is just a summary or overview of what all the issues that have to be handled at the application layer, because the cloud provider gives you the infrastructure, it gives you a PaaS environment which is automatically scalable and it's available and it is performance is very good. But still at the application layer you have to handle a lot of things, particularly if you are looking at multi-tenancy maturity model 3 and 4. Now, the standard things like exception management, instrumentation, distributed caching, things like policy injection and service injection, the data access management, all these have to be the first stack, which is the plumbing stack. Then you have the engineering stack, which handles the data isolation and the partitioning part, the authentication, the security, the access control, the ability to customize the product for different tenants differently while still having a single code base, the ability for customers to create their own queries and reports, and other things like notification emails and scheduling jobs for specific events and things like that. So these are what we call as the engineering stack. The reason why we call that as an engineering stack is because these are not domain specific or business functionality specific. These are non-functional generic engineering requirements that are required for any SaaS product, irrespective of whether you're building a HR or a finance or a CRM or any domain product. And the same way, the operational stack is also common across SaaS products, things like managing subscriptions, managing tenants, usage monitoring and metering, the various utilities to manage your database, all these issues. So today, of course, we have options of distributed caching, which is provided by many cloud providers, which your application has to be aware of and use that distributed caching so that your product is easily scalable when the load is more. Similarly, the data architecture has to be abstracted. The data connection has to be abstracted in your application layer, so that during development you don't decide where the data is, because you don't know where the data is going to be. You might eventually partition the database depending on the tenants or depending on the various modules, what we call as horizontal partitioning, where you distribute load across servers based on tenants, like first 100 tenants in database 1, 101 to 200 tenants in database 2, maybe a very large tenant separately in a separate database, maybe thousands of small tenants in another database. So you might want to distribute the database load across servers based on tenant information. That is what we call as horizontal partitioning. We also have vertical partitioning depending on the functionality, like you might have a product with multiple major modules, like let's say payroll or performance management and things like that. So you might want to have a database focused on payroll related information in one database and the performance management in another database, and maybe a common database which is the employee database, for example. So the ability to support horizontal and vertical partitioning has to be designed into your architecture right at the beginning. It has to be handled at the engineering stack level, or what we call as the framework level, so that your developers who are building the business functionalities do not have to really worry about those aspects. And similarly, data isolation between tenants. Now, you might have a separate database per tenant, you might have a separate schema per tenant, you might have a separate table per tenant, or you may even have a single table with the tenant ID for all the tenants, data being shared in a single table. But your developers shouldn't mistakenly make a mistake by not referring to a tenant ID in a query, for example. So the framework should be able to automatically filter the data for the tenant depending on the user's context or the tenant's context, without putting the load of that tenant awareness to the business layer. It has to be handled at the framework layer. So these are some of the data architecture related things that have to be done at the framework level before you start building your business functionalities and domain-specific functionalities. This is what is represented again here in the form of a diagram here, where you have a tenant's transactional data, you have metadata, as well as various types of data which is grouped depending on your requirement, apart from the central database, which could be a core metadatabase which is across all tenants. Then we move to the other important aspect of the framework, which is the authentication part. Now, you need to support federated authentication, things like SAML has to be supported. You need to provide support claims support and identity provider support and password policy support. These are all nothing to do with your business functionalities or domain functionalities, but these are all very basic, what we call as the non-functional features of any SaaS product, which have to be handled at the framework layer. Now, coming to access control policies, normally in traditional systems, the roles are hard-coded and the access controls are linked to the roles. So each administrator will then assign the roles to a particular user depending on what access control they would like to give to various roles. But in a multi-tenant situation, you might need the end customer might want to have the roles defined for their organization differently. So what is normally required in a multi-tenant situation is a privilege-based authorization, which is what you do at your business layer, at your code level, for any action or anything that you do, you demand the privilege for that. But the actual mapping of which role has what privileges and which user has what roles is dynamically done during runtime by the tenant's own administrators, so that you don't have to really hard code them in your code. So there are various ways you can do that. You might have some global roles. You might also have some tenant-defined roles. You can have privileges which are defined as part of the framework, which are then through a UI screen, administrator screen, are mappable or mapped to a particular role and to a particular user by a non-IT person. Like, for example, you are building an HR product. A HR manager should be able to map the privileges for various people in his organization using a UI screen on his own without really depending on an IT person. So these are some of the requirements of access control management in a typical multi-tenant SaaS product which your customers might expect. Then the third area is what we call as data scope policies, which also varies widely across organizations. Let's say, for example, that a CRM system, you want to say that the marketing manager should get access to data only to his territory, or in a finance system, the finance manager should get access to data only to his division, or the HR system should say that you should only get access to data to people who are reporting to you. So apart from what you can do and cannot do, which is defined as part of the privilege management, you also have to define boundaries to what somebody can see or cannot see in the system, or what somebody can do or cannot do. And there is a filtering that has to be done, what we call as data scope policies. And these data scope policies again cannot be hard-coded into the system because different organizations would like to define these data scope policies differently. So these have to be handled at the framework level, and depending on the context of the user, the product has to behave differently for different users depending on to which tenant they belong to and what is the configuration of data scope policies that have been provided for that particular customer. Some of the other things which are very important in a multi-tenant SaaS, because you are trying to host a single instance code base, servicing maybe hundreds or even thousands of customers, the audit trail becomes even more important. You need to have tenant awareness in your audit trails. You should be able to trace anything in the product to something that has happened with respect to a particular user of a particular tenant, and then you should be able to record those audits. And these have to be planned and architected into your engineering stack itself, so that at any point in time in your business layer, you could be able to turn on or turn off any audit requirements depending on the requirement of the customers and depending on the requirement of your product. This could be either time-based audits or event-based audits. The next thing that has to be handled at the framework level is the ability to encrypt data and store them in the database, because customers would expect some of the critical data, like, for example, credit card numbers, for example, or salary details or important information should be encrypted and stored because it's a common database and it's a SaaS product, and so they would want the encryption to be strong. At the same time, we have to optimize the performance. Should not encrypt everything so that the performance gets affected. So we need to have a balance between performance and encryption, which columns you encrypt, which columns you don't encrypt, and things like that. So these are some of the things which are at the engineering level, which have to be handled during the architecting of the application. And most importantly, the customization aspect of a multi-tenant product is often not really taught as part of multi-tenancy, because customization is generally considered as a separate subject. But multi-tenancy, normally people think multi-tenancy is about separating the data between tenants and sharing the database and sharing the application instance. But the moment you bring multi-tenancy, there are a lot of other demands that comes which are business driven. You cannot say that I have a multi-tenant product, I'm not running a separate instance for every customer, so the customer has to use a standard product. Our product is what we provide and nobody can customize it for their requirement. We cannot say that because the business requirement is such that the customer doesn't care whether you are maintaining a separate instance, whether you are maintaining a separate code base for every customer, or you are for saving the operational cost, you are actually going for multi-tenancy. He wants the product to be customized to his organization. So this is a very real business case where there is a contradiction between your requirement to have a single code base multi-tenant application servicing multiple customers and the customer's requirement to customize the product to suit their organization. So how do you handle that at the framework level? Things like ability to customize not only the logos and the themes and the color schemes that appear on the screens, but also customize the labels, the forms, whether some field is visible, not visible, whether a field is editable, not editable, whether a field is mandatory or not mandatory. These kind of things the customer wants to customize in his product, which your product has to support as part of your architecture. So similarly, when we go to other things like more advanced customization, like ability to create queries and reports and charts on the fly by the customers, end users, the ability to customize business rules, the ability to customize workflows. So most of these things have to be handled at the application architecture level, right at the beginning of your migration or development phase, so that it's easy to implement. Whether you may need them immediately, you may not need those features immediately, but if you don't architect them or plan for them right up front, it will be very difficult to introduce those capabilities and flexibilities after you have advanced into your development phase. So these have to be handled at the architecture level. So this is a sample screen for adding a new custom field to an entity. This is another sample screen for configuring a business rule. Let's say it's a benefit administration system and the customer wants to customize the benefits for their employees depending on certain business rules, which could vary from even division to division or organization to organization. So these have to be configured in the product. It has to be tenant. Okay. So let me proceed further to the balance parts of the presentation. So when we also have to handle notifications in your product, we need a notification engine which can send out either asynchronous or synchronous emails. It can be batch-based email notification. It has to go out from a queue automatically depending on various events that happen in your product. So you should be able to raise an event, and that event should automatically link to a particular notification template. And then from that notification template, the notification has to go. And these templates again have to be customized for different customers, because one customer A might want a different template and customer B might want a different template for the same notification. So these have to be handled at the framework level. And the next thing is about subscription management, where you might want to configure the tenant provisioning or tenant access control depending on the package that they have subscribed for. Suppose you might have a base version where you enable certain modules and features, and you have a more advanced version which some more additional features and modules have been enabled. So the access control to the product and which menus are visible and which features are accessible by the user has to be context sensitive to the tenant to which the user belongs, and in turn in terms of the provisioning that you have done in your tenant provisioning process. So these have to be managed at the framework level, and that along with the roles and privileges have to be interjected to enforce the various access control policies of your product. Similarly, you might have usage-based subscription, which is either based on seat-based subscription in terms of number of users or number of concurrent users. You might even want to have usage-based subscription. For example, you might want to limit the number of things that they can do. Let's just say performance appraisal product. So you want to say that this product has been bought where you can do up to 1,000 performance appraisals, after which you have to renew a subscription. So you can actually even do usage-based subscription, which gets linked back into the usage monitoring and metering that have to be planned at the very granular architectural level, because the invoicing and the billing and the price book management could even be done differently, and it could evolve as the business evolves. But in your architecture, you should provide for metering the granular level events and activities that happens in your product. We are not talking about the metering of the CPU usage or the storage usage. We are talking about the metering of the usage of your product, and so that they can be logged and audited and reported, and then can be interfaced to your billing system, which is your own billing system, or it could even integrate with an external billing provider's billing system, but the metering has to come from your framework. So these are some of the things that have to be handled at the framework level. Similarly, when you provision a tenant, the customer it might be a product where the customer comes, signs up, pays through credit card and automatically gets access to the product, which is what we call as auto provisioning. If it's a multi-tenant product, most of this provisioning actually happens within the application because it's a single instance and a single database, and some scripts have to be run and some jobs have to be run to provision a tenant and start giving him access. Some default roles and privileges have to be created for the tenant so that they can start using the product afterwards. Or it could be a passive provisioning where your product administrator actually provisions a tenant whenever there is a new customer onboarded into your system. The same thing applies for deprovisioning also. So apart from these operational features, some of the other things that you might need on a day-to-day basis once you have deployed your product on the cloud is the utilities. Because your data might be partitioned horizontally or vertically or both, you might need a utility to consolidate data across tenants or to back up a particular tenant's data or move a tenant's data from one server to another server. And you may also need integration utilities like ETL tools where not only for the first time onboarding of data from the tenant's system into your SaaS product, you may also need end-of-day integration with multiple on-premise systems of the customer where every day at the end of the day there is an import and export that happens between your SaaS product database, which is the multi-tenant database, and your customers' on-premise systems, where you need some ETL tools, which all these have to really come from the engineering framework level and not at the business functionality level. So, in essence, what we are really talking about is when you're trying to build a multi-tenant SaaS product, let's say on top of, for example, .NET, SQL, either SQL Server or SQL Azure or MySQL, for example. You might want to host it in Amazon RDS, or you may want to host it in SQL Azure, or you may host it in a data center, for example. Between that layer and your product-specific functionality at the top, which is what you build, the business functionalities, the domain-specific functionalities, there are a whole lot of things that you have to build first, which is what we call as the framework layer or the framework stack, which, as we explained in the previous slides, there is a plumbing stack, there is an engineering stack, and there is an operational stack. So all these have to work together and interoperate with each other so that you get tenant-level customizability, tenant-level configurability, application-level multi-tenancy, tenant data isolation, and all those things packaged so that your developers who are doing the actual development of the business functionalities, whether it's a HR product or a finance product or any marketing-related product, they only have to focus on the domain-specific functionalities and business functionalities, leaving the engineering and architectural challenges to the framework below. So this is another way to describe the process, whether you are starting a new product development or migrating an existing product from the current state to a SaaS model or a cloud model with multi-tenancy maturity model 1 or 2 or 3 and 4. Either way, you may start with multi-tenancy maturity model 1 and 2 to start with, where with a little bit of massaging your code, you might be able to go live and offer SaaS to your customers. And as you move to multi-tenancy maturity model 3 and 4, there will be further modifications and development on your product that you have to do to be able to make it compliant to a multi-tenant architecture. There, if you can build a framework internally from scratch on top of .NET, for example, or you can just buy a framework like what Texelo provides and then only focus on your product-specific functionalities. Now, once you build such a product using the framework, either bought from outside or built in-house, you then deploy it either in Azure or Amazon or your own private cloud, or you can even deploy it in a data center or even on-premise. So the advantage here is that you don't have to maintain a separate code base subsequently for on-premise and cloud. The same product can, which is the same level of flexibility, can still be deployed on-premise, on a data center, as well as on the public and private cloud. So, Milan, would you like to have any closing comments?
No, I had nothing from my side at this point, Ram. All I wanted to say was that, it's I mean, the devil lies in details. So it all depends on how we plan it and how carefully we orchestrate the whole program. But nothing from my side at this moment.
Okay. Okay, so let me wait for a couple of minutes for any questions. What kind of customer reference cases do you have to share? Okay. Now, with respect to, I will also ask Milan to answer that question from Symphony's perspective. But from a Texelos perspective, we have a couple of customers who have already gone live with their products built on top of the SaaS framework. We have published these case studies in our website download section. Please feel free to visit our website and go to the download section, and you'll find some case studies there which you can download and look at it, which will give a lot of information on how people have leveraged our framework for building their product. Milan, would you like to also talk about that in terms of reference cases?
Yeah. And actually the same applies to Symphony as well. There are a number of case studies available on the website, but in terms of customer references, we have a number of them on both the sides, in the sense that on the product engineering side for SaaS enablement, as well as for deploying these SaaS products on cloud as platforms. So in terms of platforms, they are available on almost all the leading platforms in terms of, they're available on Amazon, they're available on Azure. A couple of those are also available on pure PaaS platforms like Force.com. And on the SaaS side, again, we have a number of case studies, both in terms of SaaS migrations as well as building new SaaS products from scratch. And you will find a few sample case studies on the website, but do write to me in terms of if you're looking for anything specific, and we'll be more than happy to send you those details.
Yeah, so other questions. We have a multi-tenant solution that is live today, but reducing custom code and moving up in the value chain is interesting, but need to build a business case around that and assess the risk. Okay, that's the comment. But I assume that if it is a multi-tenant, maybe it's a maturity model 1 or 2, I'm not sure, because there is a custom code already there, maybe for some customers, which have to be rationalized and made into a single code base and make it more flexible and move it up the value chain. Yes, that is required from both a business case perspective and from a long-term operating cost perspective. And Milan, you might also throw some light on the technical challenges of maintaining multiple code bases for multiple customers, even after migrating to cloud in a model where there is multiple instances running for multiple customers with different code bases. What are the challenges involved in the operating costs and the maintenance costs?
So we have about about 180 ISVs as our customers. Not all of them are, of course, on SaaS, but there are a number of them who are there, and we keep talking to them, and there is also enough published research available that the order of magnitude of savings, in terms of moving from a multi-instance to a single instance or a multi-tenant model could be to the tune of 16x. Okay, that's the order of magnitude. Now, number of variables come into play here in terms of, what is the kind of really the diversity and how many versions and how many code bases you are maintaining. But that is the potential which exists, and probably what Ram could answer was in terms of whether even in such a scenario, if someone wants to move up the value chain, whether the framework can be used or not. And if that is the case, then whether it can be tackled through the Selo SaaS framework. But in terms of savings, again, one more thing I would like to add here, this word multi-tenancy has been used in the industry with multiple connotations. So here, what we have spoken about in this session is actually the highest level of multi-tenancy, which is shared everything, right? Which is like a single instance. But if you are talking about lower degrees of multi-tenancy, which means maybe only the database is shared or maybe only the infrastructure is shared and not the instance, and you want to move to that stage, certainly there is a merit in looking at an assessment, looking at that case, because the potential is immense.
Yes, Milind, I agree. Because there are many cases where the best way to start is to move to the cloud in a maturity model 1 or 2, where only the infrastructure and the software infrastructure, the OS, the IaaS and all that is shared, but there is a separate instance running for every tenant and a separate database for every tenant. And eventually, over a period of time, you try to consolidate that further and migrate it to a maturity model 3 or 4, which can even be a phased approach, which is transparent to your customers. So your customers will get SaaS as a service, as an offering right at the beginning, but you can keep parallelly working on migrating your architecture to a full multi-tenancy model over a period of time. It's not necessary that you have to do everything upfront and invest on re-engineering and re-architecting and then only offer SaaS to the customers. It is not necessary. So there is a ramp kind of an approach that is possible, which both Excello and Symphony can help you tailor make a right roadmap for you depending on your product, technology, and the business environment in which you are placed.
And one more thing to add here actually is that as the application or the product moves up the maturity level basically, and the customer base is growing, and more and more needs are being placed on the product, it's equally important that the ecosystem of the cloud also grows in parallel. So for those who are interested, probably we could discuss it over mails or through separate discussions, but we have created a cloud maturity model for this, which talks about how the ecosystem moves up the value chain. So when it comes to the deployments, when it comes to the operations, when it comes to managing various aspects which I spoke about in the presentation. So each one of these could start at the lowest end, probably with either not being there or being done manually, to finally a fully optimized and automated solution. So that is also an aspect which we need to consider when we move up the multi-tenancy value chain, the ecosystem aspect of it.
Okay. I think that's all, Milind. We don't have any more questions. We'll try, and thank you very much for your time, and thank you all participants for your patience and time in attending this webinar. We will be sharing this slide deck and the video recording of this webinar both in Symphony's website and Texero's website very soon. So, and we will probably send you the links as well, so you can share it with other people in your organization, your architects and your CTOs, so that this can become a starting point for further discussions on your SaaS roadmap. Thank you, Milind, and thank you, everyone.
Thanks everyone. Bye.
Thank you.